Swayam Prabha. Digital India. Educated India.
Hello everyone. So today we will be continuing from our last lecture, that is the market trading systems. So in the last lecture we talked about this cap and trade. We defined what is cap and trade as market trading system. So today we have planned to describe what is the cap and trade example. Certain examples we will be taking into account. Then we will be explaining the marginal saving functions as volatility functions, then how to determine the price per permit or how to determine the permit price, that we will be explaining, and then we will be discussing the difference between this emission tax and the cap and trade, and finally we will be discussing the last mechanism of this market based trading, that is the liability. Okay. And we will be discussing what are the mechanisms of the liability and how this liability can also provide economic incentives. Okay. So, let us start with some of the examples of cap and trade. So, as you understand, in cap and trade the government puts a cap or upper limit and that allows trade among the polluting entities. Okay. So, now we can take this example. Suppose the government has introduced a cap, the upper limit of the emissions, and this trade scheme then will reduce the amount of these emissions. So, now let us take an example of cap and trade. Suppose say the government has introduced this scheme, cap and trade scheme, in order to reduce the greenhouse gas emissions that are emitted from the power plants. Okay. And here the current total emissions that is estimated is 1,50,000 tons per year, right. And the policy makers, how they obviously want to reduce this level of emissions from this 1,50,000 tons per year to 1,00,000 tons per year, right. So, this is the cap the government has fixed. And obviously here in this emissions there will be lots of farms in this industry, power plants industries. So, we can take one single power plant, right, and this one single power plant, it is currently emitting 5,000 tons of emissions, this greenhouse gas emissions per year, right. And under this cap and trade, the upper limit that is fixed for all the industries at a macro level or in total, the government needs to reduce this emission level from 1,50,000 to 1,00,000 tons per year. However, for individual industries, this cap provision is fixed, that means a permit is allowed till 2,500 tons of emissions per year, right. So, here for individual farm the cap is fixed, that is the individual farm can emit 2,500 tons of emissions per year, right. So, in this case now the question is, what are the strategies that needs to be adopted by the particular industry here. So, now this power plant manager, he would be thinking about some alternatives. So, what are the alternative choices available in these situations? Let us see it. So, when the power plant it is right now producing 5,000 tons of emissions per year, and government has permitted till 2,500 tons of emissions per year, right. So, in this context the manager would be having some alternative choices. So, what are the alternative choices? The first can be the manager would be thinking to reduce the emissions to the initial permit level, that is 2500 tons per year. So, that means simply to reduce from 5000 tons of emissions to 2500 tons of emissions per year. So, this is the first option, that reduce the emission to the permission level. The second one could be the manager would be thinking that let us continue with the same 5000 tons of emissions per year, but obviously the upper limit is 2500, that is allowed limit. So, for that reason the additional permit needs to be purchased. So, what is the additional limit? How much? So, it is 2500 is permit level, and it is right now it is continuing with 5000. So, obviously additional permit of 2500 tons per year needs to be purchased, right. And the third alternative choice is that the manager can think of to reduce its emissions below the allotted limit. So, what is the allotted limit? 2500 tons per year, right. So, now the manager would be thinking to reduce this emission level below 2500 tons per year, and the surplus can be sold in the market. Okay. So, this is the three different alternative choices in the scenario of the cap and trade. So, now we can take another example, right. So, let us assume a situation where two polluters are there. So, what the government is interested to reduce the pollution, that the government can allow maximum 100 units of pollutions from both the industries. Okay. And then now the government is thinking that let's start with 50 permits for each of the polluting industries. So, in this case, what would be the marginal savings from polluting functions for both these farms? So, let us talk about farm 1 and farm 2. So, we can find that if in the horizontal axis we are depicting the permits hold, and in the vertical axis the price for it, right. Then we are saying that this MS1 is the marginal saving functions for farm 1, right, and this MS2, this line, right, is the marginal saving function for farm 2, right. And for the initial point for the first farm 1 is starting from 0 till 100, and for the second farm where we have depicted this marginal saving MS2, the initial point for second farm is starting from here, it is 0 here, and it goes on till 100, right. So, in this exercise the equilibrium price for permit to pollute is determined by the intersection point of this marginal saving function of the first farm and the marginal saving function of this second farm, and at this point of intersections we are finding this E star is the equilibrium holding of permit, right, and corresponding to this E star the price is known as the permit price, right. So, now the equilibrium price, that is P star, is the permit price, and E star is the equilibrium holding of the price, holding of the permits, right. And now if you are thinking of a pollution tax or emission fee, you are saying, then when the government is going to impose any emission fee, then this emission fee would be, the amount of emission fee would be just equivalent to this P star, right. And so, you can say this emission fee of P star is going to achieve exactly the same outcome, right, as the case of marketable permits, right. So, this is how we can say that we can compare with this marketable permit with the emission fee, right. So, now we can find the equilibrium permit holding is E star. However, the government is deciding that only 100 permits can be allowed, and for both the farms the government has distributed the share of this permits into 50-50. So, that means first farm 1 is holding 50 units 50 permits, and farm 2 is also holding 50 permits out of 100. But what we are finding here, that this equilibrium holding is E star, that means the farm 1 is holding, is polluting at E star, which is much more than the 50 allotted permits, right. And similarly, farm 2, its allocated share is 50, however, it is producing much less than 50, that is at this E star, right. So, in this case, what will happen, as farm 1 is producing much more pollutions than the permitted one, then in this case the farm 1 will be purchasing this extra permit from obviously farm 2. What is the extra permit? So, this level E star minus 50 is the extra permit that farm 1 needs to purchase, right. And obviously the farm 2 is going to sell, because it is using, or it is polluting E star, whereas it has the apportionment share of 50 permits, right, which is less than 50. So, this trading procedure, it can be continued till farm 1 holds E star of permits, and farm 2 will be obviously holding how much? 100 minus E star of permits. So, till this point is restored, the transaction can be continued. So, from this what you understand is that if the marginal abatement cost, it is greater than permit price. So, in this case, whether the farm would be purchasing the extra permits, or it would be going to sell the permits. So, when we are saying the marginal abatement cost is greater than the permit price, then obviously the pollution control or reducing the pollution is a costly affair than to purchase in terms of permit price, right. So, for this reason, what the farm will be doing? The farm will be purchasing the extra permits, right. And in the opposite case, if the marginal abatement cost, it is less than the permit price, then obviously the farm will be trying to abate more and more, and it will be selling the permits, right. And in this case, if you are assuming a pretty good number of farms, polluting farms in an industry, then these mechanisms of transactions, buying and selling, right, it will actually push till the agreed marginal abatement cost gets equivalent to the price of the permit. So, till this point is reached, this procedure will be continued, right. So, here this marginal abatement cost is taken as the demand for permits, and what is the supply side? Supply of permits. So, it depends upon the regulating authority, that how much permit is to be allowed for the industries itself. So, this in the demand side, this agreed marginal cost, it will be constituting the demand for permits, and in the supply side, the supply side of the permits, it depends upon the regulating authority, that how many number of, what is the amount of permits the regulating authority is going to allow. So, now after understanding this demand and supply factor, supply side of the permits, we can determine the price and quantity in the permit market, right. So, as you understand, the demand for permits is represented by the aggregate marginal abatement cost function of the farms, and the supply for permits, it depends upon the quantity of permits that is allowed by the regulating authority itself, right. So, if you are drawing this representing in a graphical manner, then we are finding this is the aggregate marginal abatement cost, which is the demand for permits, okay, and this SP is the supply for permits, which is fixed by the regulating authority, how many permits are allowed or what is the unit of pollution to be allowed. So, in this case the intersection point of your demand for permits and the supply of permits, right. So, intersection point is here. So, the equilibrium quantity is Q1, okay. So, this and the equilibrium price is P1. So, what you can say that in this case Q1 is the supply of permits, right. and that is how we are saying the price per permit or permit price is P1, okay. So, in this case if the government, after finding that this is the equilibrium Q1 and equilibrium price is P1, then if the government would be thinking to even restrict or even reduce further reduce the pollution amount, then obviously it will be providing less number of pollution permit in comparison to the initial pollution permit, that is SP, right. So, if the government is taking some restrictive permit, right, from reducing from the first, the original state of permit is SP and now it is reducing further, then the quantity will be fixed or the equilibrium quantity will be determined by the intersection point of this supply curve, this is SP dash with the demand curve of the pollution permit. So, at this point we are finding the Q2, right, this is the quantity and the price against this Q2 would be the P2. So, the permit price would be P2 and permitted quantity would be Q2, okay. And likewise, if suppose say the demand curve for the permit, it shifts upward like this, okay, then what will happen? So, obviously, in case of this first supply curve, now the demand curve is shifting. So, obviously, the price given the quantity, the same quantity is there, same quantity of permits would be there. However, the price would be rising from P1 level to this level, okay. So, likewise, if you are talking about this the second supply curve, now the demand curve has shifted, okay. So, now for the second one, the equilibrium point of intersection would be this, and again given the same amount of permit Q2, the price would be rising from P2 level to this level, okay. So, in this case the cost effectiveness in trading of this permit, right, it requires that there would be a single market and single price of the permit, right, and all the transaction plants who are involved in this particular transactions. So, they will be trying to equate this marginal abatement cost with this single price. So, if it is for the first case of limit, if it is this P1, then all these plants they will be trying to equate their marginal abatement cost to this price level, okay. So, that means you are saying this equimarginal principle will be followed. So, if you are talking about two farms, then we will be saying this marginal abatement cost of the first farm would be equal to marginal abatement cost of the second farm, that is equal to the P1, okay. So, now let us understand the difference between this emission tax and the cap and trade. So, in our earlier discussions we have understood what is the emission fee or emission tax. So, in case of the emission tax, what you are finding? You can just remember the case of emission fee. So, in this case, this under this emission fee, the marginal cost of emission control, it can be known precisely. Why? Because when you are paying the fee, then obviously the cost of controlling the emission is known, right. And when you are going to reduce one more unit of pollutions, then you have to pay some additional amount of cost. Okay. So, that is how the marginal cost of emission control is, it can be precisely known under the emission fee. But so far as the quantity of pollution is concerned, right. So, in under this emission fee, this quantity of pollution is less sure to be determined. Whereas, in case of marketable permit, you can just remember what happens here, the upper limit or the permission for the pollution is granted, right. So, that means the amount of pollution it can be known, but which one would be lesser known? Then the lesser known we can find that this marginal cost of pollution control, it will be less sure or will be less sure about the marginal cost of pollution control. So, why it is so? Because you know that under this cap and trade, this quantity of restrictions or what would be the upper limit of pollution, it is fixed, right, by the regulator itself. And all the polluting firms, they are asked to adjust their emissions that determine the permit price. Whereas, in case of emission free, the per unit emission fee is fixed by the regulator itself, and the firms adjust their emission level. So, that is why under this emission fee, this marginal cost of emission control, it is known, whereas this marginal cost of whereas the quantity of this pollution is lesser known, and in case of marketable permit, this amount of pollution is known, but the marginal cost of pollution control is less sure. Okay. So, now let us talk about the last method under this trading, that is liability. Okay. So, what is liability? So, here the basic argument of liability is that if you are doing any kind of harm to someone, then obviously you have to pay for the damage that you are causing. That means you have to compensate that person for the damage you have caused, right. So, let us take an example. So, when you are talking about the hazardous waste storage management facilities, right, or simply saying we are saying we are when you are managing a dump, right. So, the task is that when you are maintaining a dump, right, you need to take certain steps. So, what is the steps you need to take into account? You need to minimize the risk of this waste hazard. So, how to minimize this risk hazards? Because you are maintaining, you are the owner of a dump, then your priority or your task is to minimize the risk of hazards, but how? So, it depends on how you are taking to what extent you are taking the precautions to minimize the risk of this hazardous waste. And you know that when you are going to take precautions, it is costly affair. So, precaution is very expensive, and assuming this ceteris paribus assumptions or other things taking constant, the dump owner obviously would be preferring to take less precaution because precaution is costly. And moreover, when the precaution is not taken, the damage to the society would be more. So, the damage to the society, it depends on the precaution level that the dump owner is taking into account, right. And how about both costs, that means to dump, it is also costing you, and if you are not taking into account the precaution, it is also going to cost to the society. So, to dump and whatever the damage we are getting and the society is suffering from the damage, these are the functions of the level of precautions itself. Okay. But now the thing is that what is the socially desirable level of, or what is the social optimal level of precautions that the dump owner needs to take. So, you need to find this socially desirable level of precautions, right, we can determine it. So, this point can be determined at which the marginal cost of taking one more precautions are just balanced or just offset by the reduction in the marginal damage from taking more basic regulatory mechanisms, and this will be giving economic incentives by reducing in the marginal damage from taking one more precautions. Okay. So, what is the point that we are finding? So, which is known as the socially desirable level of precautions. So, we are finding that point at which the marginal cost of taking more precautions, it is just offset by reducing the marginal damage from taking some more basic regulatory mechanisms. Okay. So, now let us talk about how this liability is also providing economic incentives. Okay. So, you know that when you are neglecting, right, for this liability or negligence of the liability, it will mean the fear of being responsible. Okay. So, liability is fear of being responsible, but when you are neglecting, that means you are not afraid of being responsible, right. So, what is this fear? The fear is that if any accident damages occurs, right, and this accident damage, this liability, the very idea of liability, that if some accident happens, then you need to compensate for that. It is actually acting as a sufficient incentives to take right kind of precautions, so that the society would not face any kind of damages, or you can say the socially desirable amount of precaution can be taken. And because of this very idea of the liability, so the polluters now they would be getting economic incentives to compensate for the damages they have generated, right. So, this is the basic understanding of liability, that if your action is creating any kind of damages, then obviously you are responsible and you need to compensate the victim. So, now we need to understand what are the mechanisms of the liabilities that is leading to the economic incentives. We can take this example, that how this liability principle is working, right, by taking into account the same demand and supply concepts of liability. So, as you understand that what is the demand curve for liability? It is the same marginal abatement cost, and what is the supply curve for the liability? It can be represented by your marginal damage, right. So, we can just graphically represent this. This is your marginal abatement cost, right, and this is your marginal damages. Why marginal damages are not starting from 0? Because the nature is also having certain absorption capacity. That is why whenever the pollution starts, it may not actually affect the society, it may not actually harm or damage the society itself. So, that is why after this point of this capacity, natural absorption capacity, we are finding this marginal damages. Okay. So, our task is to find out what is the efficient level of liability or efficient level of emissions. So, it is determined by the intersection point of this marginal abatement cost curve and marginal damage cost curve. So, this is determined at this equilibrium point. So, accordingly E star is the efficient level of emissions. So, here in the horizontal axis we are representing this amount of emissions, and in the vertical axis we are representing the pies for the same. So, this is what the society is needing, this is the societal level of emissions, it is desirable. So, however, if you take into account the actual level of emission, let us say the actual level of emissions is not taken place here at the societal level of emissions, rather at a larger extent, that is at the U1. Okay. So, obviously this U1 level of emission, it is much more than the efficient level of emissions, that is U star, right. And when we will be saying that liability rule is here, it is applicable. So, in this case, what is the principle of liability? That means, if there is any kind of damage, it needs to be compensated. So, following this liability principle, this damage, whatever the damage it has created because of its production at E1, emissions at E1, so this damages has to be internalized, right. So, what is the cost if the industry is producing at E1 level of emissions, what is the cost or what is the damages? So, damages are this is damage function. So, this is these under these, this is B area, C area, D area, the whole of these, right, it is the total damage, right, damage cost. So, that means this total damage cost needs to be compensated to the victim, or the polluters needs to pay this B plus C plus D area of damage, right. But now the thing is that how to decrease this compensation cost, because obviously the polluter would be thinking how to decrease this compensation cost. So, now the polluters can decrease the compensation cost obviously by, if the polluter is going to decrease the level of pollution from E1 to less than E1, and it can continue till E star is achieved. Okay. So, polluters can actually decrease the compensation cost by reducing this emission from E1 towards E star, and thereby what the polluter would need to do, it has to go for investing in terms of abatement cost, right. So, it can reduce these emissions to a point, which point, as long as this marginal abatement cost is less than the marginal damage. So, this portion is the marginal abatement cost, which is less than the abatement, this marginal damage. So, after getting here, at this point marginal abatement cost is just equivalent to your marginal damage cost. So, after reaching beyond E star, what you will be finding? This marginal abatement cost is more than the marginal damage cost, right. So, the polluter would be reducing the emissions till the marginal abatement cost is less than the marginal damage cost. Okay. So, you can say this marginal abatement cost, it is less than the marginal damage cost till this point. So, now the liability would be acting as an economic incentives, okay, by reducing the pollution automatically to E star level, which is the efficient level of pollutions. Okay. So, this is the principles of liability, that if you are creating any harm or damages, you must compensate. So, that is why, so the polluter needs to reduce in order to give less compensation against the damages. So, that is how it is the efficient level of productions. Okay. So, for liability portion you can follow these books, Environmental Economics, Field and Field, and also you can follow this Cold Start book, Intermediate Environmental Economics. Okay. Thank you very much.